let's get started. I think we got most everybody here. So I know myself that I'm going to forget to say it later. I'm not in town tomorrow, so I'm not going to be available to help you guys with, questions during the day, etc. But I'll definitely, get to my messages Monday morning, things like that. So if you guys run into questions, whatever, feel free to ask away. I did put everything up in the folder for tomorrow, though. So what my plan is kind of to try to teach you everything today, if possible. So I'll try to cover today's material and tomorrow's material. I don't know if we'll get that far, but we'll try. Okay, analytical limits. So we've done limits from a graph, and we've done limits from a table. And to be honest, analytical limits are the most common. So these are trying to find limits just from writing an equation. And there's kind of a process that you go through to try to find these answers. So I'll start with a straightforward example. Correct, Carson. Correct. So tomorrow, all you guys need to do is actually log in and take attendance. Or at least that's what they told me. So you're supposed to log in tomorrow, take attendance, and then I'm supposed to put attendance in on Monday when I come back. I don't know how that works, but just correct. Tomorrow, all you need to do is take attendance. Let's do the limit as x approaches 2 of x squared. Now, I picked this one because I thought it was kind of a nice and easy one that most of you guys would know what it looks like. And so in your head, you can kind of already picture this one, right? So traditionally, analytical limits, you're absolutely not going to know what they look like because the equations are going to be strange and you just go with what the equation is, not the picture. So I picked x squared because I know you guys will. Sorry, I forgot. I didn't see who asked that one. Carson, I think that was you. So the Khan Academy assignments, they're not technically, there is no actual assignment each day. Basically, our goal is to be done with the whole unit in 11 days. So, okay. Sorry, I didn't see who asked it. It was just out of the corner of my eye. So the assignment for tomorrow is still there. What I did was I just broke up the 11 days that we have for Unit 1. And I kind of made the assignment split up evenly over the days. You guys are always welcome to work ahead. If you get behind, you can try to catch up, things like that. So it's not so much that we have individual assignments daily. Pretty much what I put in Schoology is just so you guys can keep the correct pace to be done on time. You're always welcome to work ahead if you know you got lots of things coming up. Say you have work tonight and you know you're not going to be able to work on everything. Well, then tomorrow you can basically try to do 2 days worth of work, So there still is assignments tomorrow, but it's just basically I split it up so you guys know what you should probably want to work on. I never actually have anything like this class is too difficult for me to say you have to do this today because some things take a long time, some don't. I basically have work for the whole unit that we just kind of work on, and we have a set amount of time. Okay, so limit of x squared as x approaches 2. So I know this looks like, wow, that was absolutely horrible. We're going to pretend that I didn't draw that one. So that's good enough. So we know x squared looks like this. And who should we go with? We should go with Connor. Connor, can you help me out? Do you remember how to find a limit? Do you remember what a limit means? Is that the best way to ask the question? What does a limit mean? Like, that's perfect. My guess is you read it from somewhere, but that's all right. That's why we write them down. That's exactly why you write them down. No, that's perfect. So the reason I wanted to ask that question is if I'm looking at this picture, technically I'm trying to find what is the value of x squared from the left, what is the value of x squared from the right at x equals 2. Well, we all know what the answer is because this is a continuous function. Like, there's nothing missing. There's no holes. There's no anything. We all know that those are both pointing at a height of 4. X equals 2 has a height of 4, and we all know that because we can plug 2 directly into the equation. So if you are trying to find an analytical limit, the first thing you are always going to try, and I'll write this down so you guys have something. First thing to always try when evaluating limits is to plug in the number. Now, the real wording is direct substitution. I don't always like real wording. So, the first thing we should always do when we're doing a limit is plug in the number. If you can plug in an x value and get an answer, then that means the function was continuous and the function value is the same as the limit. So this part might take you a while to get. On a continuous function, a limit value, so a limit means coming from the left and from the right. On a continuous function, the limit value and the function value are the same. So a function value means you plug in the number. A limit value means you look from the left and from the right. So they mean different things, but they can have the same answer. Now, this would be the most simple thing ever if all we had to do was just plug in numbers. So, I mean, like, I'm pretty much going to give you the bad news that this rarely will happen. You'll get a couple of these, and actually on the AP test, they always have one of these, because some people don't even think to try to plug in the number because they're so used to trying other methods that are harder. So the first thing you're always supposed to try is to plug in a number. And if you get an answer, you're done. Now, moving on from that, very few of them ever actually let you just plug in a number. So let's try this one. So the limit as x approaches 1 of x cubed minus 1 over x minus 1. And we definitely, who should we call on? We should definitely call on Julia. Julia is going to be our professional helper. I didn't ask one yet. I was just trying to find a ringer that could come in and like teach the class for me. So, my question was, what happens when we try plugging in 1? Okay, how come? I mean, like, you're correct. Perfect. So if you want to say that's undefined, that's okay. This is actually going to be called an indeterminate. So there's actually more specific undefined things. So this would be an indeterminate, which doesn't give you any kind of answer. So plugging in 1 doesn't help us. Well, I know that a denominator having x minus 1 means that we're going to have a whole or an asymptote or something. It basically tells me that this graph isn't continuous. This function isn't continuous. Because we can't plug in 1, it's not continuous. So we have to try something else. Like, we have to try to figure out another way. A big part of calc is learning how to manipulate equations. So what we want to do is we want to take x cubed minus 1 over x minus 1 and change it into something else. Lucas, do you think you can help me on this one? What do you think we should try to do? What did we do a lot of in pre-calc and Algebra 2 when you had polynomials? Basically, you spend months of each class doing this. Perfect. Absolutely perfect. Now, it's okay if you don't remember how to factor that. I just wanted you to be able to remember that topic. So yeah, nice job. That was a very nice job. If you guys see polynomials, one thing that should immediately come to your mind is factoring. So this is the part of calc where I'm trying to think of a nice way to say it. If you are a person who kind of skeezed your way through pre-calc, maybe Algebra 2, this is where you're going to be hurting in calc. Because if you didn't actually learn how to factor and you kind of just tried to... I think if I remember right, Mr. Sardini calls you the... What did he call it? The odd all-stars? The people who like to use the back of the book or Slater to basically do their homework. This is where it's going to hurt because you're going to have to know how to factor this. And I think a lot of you are going to forget it. So you're going to have to try to do some work to remember factoring if need be. So the top is called the difference of cubes. And it would factor into x minus 1 times x squared plus 1x plus 1 squared. Now, I don't know if you remember me saying it yesterday, but you guys are welcome to use like the formula sheets and things like that this year. So a really smart thing for you guys to do is going to be to create note cards for each unit. So for unit 1, it might be a good idea. This is a great way to like review yourself, like to get ready, is you can create like formulas on one side of the note card, and the other side of the note card kind of like go over the types of problems you're going to get. So this is limits with factoring. Well, I can tell that x minus 1 will cancel. So that means I can rewrite my limit as x squared plus x plus 1. Now, these technically aren't the same equation. They're called equivalent. This bottom equation is a simplified version where you technically can't use x minus 1. So it would have a domain restriction, but, whatever. The awesome thing about this equation, Caitlin, what is the awesome thing about this equation? Absolutely. Nice job. What do we get? 1 plus 3. I suppose I should write that in case you guys want that. You can plug in 1. So that would be your limit value. Now, normally, if we were, in regular class here, I would have you guys, definitely do some examples and try some on your own. But because we are in such a time crunch, I'm gonna move past this one because factoring I think is something you're pretty familiar with, and I'm gonna have you guys try some of the harder ones, the harder styles, not factoring. Does somebody have a question on this type of question, like the factoring? Is there something that maybe you want to ask about, like unsure of? Okay. I will go on to the next style problem. Let's... Okay. These look scarier, no doubt. You know what? I don't remember who I've called on, but Haley. Haley, what would be the first thing we should try to do? Perfect. And when we do that, what happens? Which, convenient. Yeah. Oh, nice. You even wrote down that word. Nice. So this is an indeterminate. It is totally fine if you guys call it undefined. Okay. So I'm just trying to teach you some of these words ahead of time when you're going to need them in a unit or two. So basically, you just don't get an answer. And same thing. The bottom, there's a hole or an asymptote or something. And if you were to graph this, you actually wouldn't be able to get an answer because your graph couldn't give you 4. So we have to try and manipulate the... And this is the one where it's not going to be obvious to you. So I'm going to... You guys actually have learned this method before. And you actually did it quite a bit in pre-calc. And that's part of the reason for pre-calc, right? In pre-calc, they teach you things you're going to need for calc. You guys learned rationalizing. Rationalizing is a method where you multiply by the conjugate pair to turn something that was ugly into something that was nice. I mean, that's kind of what it was for. The main place you guys used it, and I'll erase this, you guys used rationalizing in this, where you multiplied the bottom by square root of 2. And so the bottom went from ugly to nice. That's kind of it. That's how you guys used it a lot. We're going to do the same thing. We're going to multiply by the conjugate pair, it's called. So I'm going to choose the portion of the fraction that has the square root. That's the one I focus on. And obviously, ugly is probably not a good term at all. But like most people just recognize what that stands for. So the top is what I focus on because the top is the worst. So I'm going to multiply the top and bottom by square root of x plus 5 plus 3. So I'm going to purposely change the symbol in the middle. And the reason I do that is because the top is now a difference of squares. So if I FOIL out the top, that's a difference of squares, and that works out nicely. So square root of x plus 5 times square root of x plus 5 would become x plus 5. The middle terms all cancel out because square root of x plus 5 times 3 and minus 3 times square root of x plus 5, they cancel out. And then you got minus 3 times plus 3, which would be minus 9. So the top works out nice. The bottom does not. Like, this seems like it did not help us at all, because the bottom is even worse than it was before. Now, here's going to be the trick. These questions are planned to work out perfectly for you. Don't multiply out the bottom. And I say that because if I look at the top, x plus 5 minus 9 turns into x minus 4. So these questions are actually laid out to work out for you. So that actually cancels out. And the only reason this is a big benefit to us is because that x minus 4 on the bottom was the reason we couldn't plug 4 in the beginning. So we've now changed our equation to look differently. There'd be a 1 on top. You know, when something cancels, it'd be a 1. And now that we've changed the equation around and we got rid of the part that made it divided by 0, now we can plug in 4. So it'd be 1 over square root of 4 plus 5 plus 3. So 1 over 3 plus 3. Now my guess is this is going to be probably the most difficult out of today for you guys, just because you haven't practiced many like this ever. Before I'm going to give you guys one like this to try on your own. But do you have a question on anything we did up there, like maybe why we did something or other? Not in this unit. So what you're asking is absolutely valid, because a lot of times you're going to try a method and it might not help you. So in that case, the method you tried didn't work, and so you would try something else, like you would start over. Or it's actually technically possible that you're not always able to find an answer. So, like, we're going to get problems eventually in calc that you just can't solve. And that's part of the learning process for you guys, is to learn what things to try to find an answer. Okay, here, can I repeat why I changed it to positive 3 instead of negative? Oh, yes. So you change this symbol here, because then when you multiply out the top, but it doesn't have to be the top. The square root could be on the bottom as well. So it doesn't matter if it's top or bottom. The reason you change it to a plus 3 is because then these are difference of squares. If you remember way back from Algebra 2 and pre-calc, you did a plus b times a minus b. Like if you multiply these two out, then the middle term cancels. So they call that a difference of squares. And that's the whole reason why we changed that symbol, is because then it makes it work out nice when you multiply it. Okay, here, let me write down an example for you guys to try. The limit as x approaches 0, x plus 1. This one's actually quite a bit more straightforward, so I thought it would be a little bit easier for you guys to try on your own. But then, like, the pink one I wrote is, a harder example, which I think would help for you to be able to look at. So take a minute or two, see if you can try to figure out that answer. How do we know if there's an answer versus? So Isabella, I'll just say in this unit you won't get any of them that don't work. So every question we do for a while, we'll be able to work with one of the methods we know. It's actually not for quite a while, like Calc 2, Calc 3, that you run into questions that just can't be solved, and you have to know when to do that. So it works better for you to get familiar with the methods you learn before you get thrown at you like ones that don't work. Yeah, no. So everything for this entire trimester for sure will work. Let's see, who haven't I called on? Alyssa, I don't think I've called on you. Even if you're not done, can you tell me like how to start or anything? Perfect. Do you want to keep going? Oh, nope. No, that's perfect. That's why I wasn't sure where everybody was at. That's, oh, okay. Correct. Yes, this is one of the hardest things about me not being in the classroom is it's super hard to have a feel of where you guys are at on things. So the top would be x plus 1 minus 1. The bottom would be x without multiplying out. Run out of space. Here's the most annoying thing about limits, is that you have to keep rewriting limit over and over and over. Because that's proper notation. Okay. So the reason I had called on Alyssa for the first step is by far where all of the work is. Everything after the first step is just algebra. Like you're just multiplying stuff out, simplifying. The first step on this is basically like the calc part, like the new thing. And it's entirely possible to make errors in the rest of the problem. Like that's entirely possible. That happens. But the first step is by far the hardest and most important step, and that's where people usually get stuck. I also wanted to point out that I tried to do these problems in 2 different styles, and I don't know if you noticed the difference. So both of these styles are kind of acceptable ways to do your work. If you look at the one I did in pinkish, right? So on the left, I wrote the problem. On the right, I did all of the scratch work and the simplification separate. And then I took the original question and then I rewrote it with the simplified equation. And then that's one way to do it. When I say acceptable, I mean like AP acceptable. So I did all my scratch work on the right separately. The second problem, the one you guys just did, if you notice, I did all of the scratch work within the problem. And then if you do that method, which honestly is probably the more popular method, if you do this method, you have to make sure to rewrite limit each time you simplify a line. It's super annoying, but just letting you know that that's kind of the correct way. One thing I didn't mention, which maybe I should, I don't know if I want to call on anybody for this one. Maybe Jack McManus. How come I didn't write limit right here. Yeah, where we got the blue arrow pointed. Okay? I mean, it's hard to explain, so what you said is good. So I stopped writing limit because I plugged in the number. So basically, I was just simplifying this equation all up until this step. And then as soon as I plugged in 0, then I stopped writing limit. Because this is a step where a lot of people get stuck in the past years. Like, confused as to when to stop writing limit. So you don't write limit after plugging in number. Okay. We go to what? We go to 11:15. Okay. So we got time left. Right here. Yes. Right here, when you cancel an x, canceling doesn't actually mean it like goes away totally, like erases it. Canceling kind of means we divided top and bottom by x, and it would leave a 1, like it reduces the factor. So there's a 1 on the top from canceling this. Plugging in 0 means I'm only putting 0 in place of x. So if x is approaching 0, I only put 0 in place of x. Nope, good question. How about anybody? I mean, like anybody else, feel free to ask away if something up here doesn't seem right. Okay. So, do you want me to move on? Or would you like me to give you another example to try? I'm okay with either. All right. I'll move on. I absolutely. I'm usually pretty flexible on what we go through because I try to change the teaching to fit where you guys are at. Okay, so this was today. Basically, everything I just taught you was what's listed today for Khan Academy, for like the due date stuff. So I'll start teaching you tomorrow's. I don't know why, but that's how you spell squeeze, isn't it? That seems wrong. That seems wrong, but I think that's right. So it's called the squeeze theorem. And you guys are not going to have to prove this or anything, right? So I'm just trying to explain this theorem because this theorem is how they came up with a couple of special limits that you can't find answers any other way. Actually, I'll write them down to start with. Maybe that's a good idea. So this will explain... Oh, they screwed up a squiggly line. There's two special limits. I call them special trig limits. And that's because these limits weren't able to be done with any normal method. Okay, before I go on, before I teach you how they found this answer. We can't plug 0 in because you'd get 0 over 0, which would be an indeterminate. You can't factor that. You can't rationalize that. There's really nothing we can do. And we cannot cancel those x's before somebody tries to say that. That x is an angle, which is not the same as the x on the bottom. So since you guys are all on your computers, and I'll go to my computer number 2 to type this one in. Graphing this on the TI-84 looks like garbage. Because the TI-84, you know, it's got pixels, right? And it's kind of like old school pixels where it's not very clean. So I'd like you guys to go to Desmos.com. And I'm sure you've heard of that one or gone there before. So if we open up a new tab, go to Desmos.com. Whoa. Oh, they changed Desmos. Oh, graphing calculator. Okay. On Desmos.com, we want to graph sine of x over x. And I can't remember if you have to type a parentheses to start with. It's been a while since I used Desmos. No, you don't. So if you just directly type sine of x and then hit the division key, which is the slash, it'll automatically write a fraction. Okay, so if you look at this graph, we can definitely tell the answer. We can definitely tell the answer is going to be 1. I mean, like, I guarantee nobody knew what that graph looked like, right? Because it's kind of a weird equation. And how should I say this? Looking at a graph or a table isn't a real answer. So you're basically have to like prove things in math for that to be able to use those answers. So we can't look at a graph and say, well, I know the answer is 1. We actually have to have a way to prove that the answer is 1. So both of these, and if you want to graph 1 minus cosine x over x, you certainly could too, just to see what that one looks like. But for both of these, they used what was called the squeeze theorem to prove this answer. And this is the best explanation I can give. So I'll stick with pink being sine of x over x. And you know what? That's actually, let me erase that. If I zoom in a lot on sine of x over x at 0, it'd look like a flat line. So we'll pretend I'm zoomed in. And if I have an equation that is always above sine of x over x, so greater than or equal to sine of x over x. So that just means it's always above or the same. And if I have an equation that is always below or the same as sine of x over x, you can think of sine of x over x always in between these other two. Well, if I focus on x equals 0, and g of x, if I plug 0 into g of x, and I get an answer of 1. And h of x, if I plug 0 into h of x and I get an answer of 1. The squeeze theorem says that if the equation above yours has an answer of 1 and the equation below yours has an answer of 1, then you obviously have to be squeezed in between them at an answer of 1. And so if you guys take Calc 1 at college, because if a lot of you are going into a major that requires Calc, you're going to have to retake it anyway. Usually the colleges force you to. Most colleges actually have you go through and prove these things. AP doesn't require us to prove things. So I'm just trying to explain to you how they found these two as answers. And so I'm hoping I didn't lose you or confuse you. You don't have to know how to do this. It's just kind of important for you to know that these things exist and that that's how they proved these two answers. They used the squeeze theorem on both of these. And I could go look up what equation was above and what was below. I know I've seen it. It's not a big deal. But if I have a trig question, that I'm trying to find the answer to, I can't plug in 0. I can't factor it. I really can't do anything to it. But I do know it looks a lot like the special one. I'll use a different letter instead of X so you don't get confused. I'll use a U because that's common in Calc. Even though I'm really bad at writing a U. I know this white one looks a lot like this one. Jessica Telstad. What's the difference between the white one and the green one? Okay. No, you had said exactly what I was looking for. It's the 3x and the 5x. Now, I think if I remember right, you said that this one had numbers. And it's actually okay to have numbers. So I wrote a U. And that can stand for anything. But the important thing is the one on the bottom has to be the same. Whatever the angle is on the top, the bottom has to be the same thing. So if I'm looking at this white one, they're not the same thing. So what I'm going to do is I'm going to manipulate this equation until it looks like the green one. That's our calc way. Our calc way is to change things till it works for us. So we're going to use our limit properties that we learned yesterday to help us do that. This has nothing to do with the limit property. Does anybody remember why we cannot change 3x? This might be going back into too much trig. Eric, I could tell you have a thought. Okay, that's a good way of saying it. Very good way of saying it. It's an angle. The only way you can change angles is if you use those angle replacement formulas that were horrible. Do you guys remember the half angle identity and the double angle identity and the sum? You guys learned them. They're no fun. That's the only way you can change an angle. So the bottom is actually what we're going to focus on because the bottom is just a normal 5 times x. I can work with the bottom. I'm going to take this 5 and pull it out as a multiplier. And I'm going to write 1/5 limit as x approaches 0, sine of 3x over x. Oh, yeah, I didn't really write parentheses. That doesn't matter. Okay, I want the bottom to be the same as the top, because then that matches my formula. So I'm going to use more properties. I'm going to multiply the bottom and top by 3. Because that's just like fraction properties. Like you can multiply top and bottom by the same. But the 3 on the top, I'm going to bring out front. And this becomes 3/5 times the limit as x approaches 0 of sine of 3x over 3x. So this was basically us just manipulating, changing until it fits what we need. This equals 1 because I've got the top and the bottom to be the same. Basically, when this formula matches something, I can put 1 in place of it. Let's go, who should we go with? I don't know. I don't know who I've been called on. Matthew? I don't know if I called on you. Either way. So my final answer ended up being 3/5. If I look back at the original question, can you see the pattern that would automatically be able to tell you the answer on the AP test? Perfect. Perfect. So this is the question they have on the AP test every year. Every year they give you this question on the AP test, and they change those numbers. And it's a multiple choice question, so there's no work that needs to be shown. You could just answer those two numbers, just because it works out the same way every time. Oh, actually, Julia, that's a super good question. If x is not approaching 0, then you should just plug the number in. The only reason this one doesn't work is because x is approaching 0. Actually, I could totally see them doing on that in the AP test. I could see them putting a different number instead of 0. And then in that case, you just plug the number in to get the answer. No, that's a good question. Okay, do you want me to... It looks like we have enough time, but I also know that approaching an hour is kind of like what your brains can like take. I totally get that it's super hard to sit through calc for a long time. That's why these block hour-and-a-half classes are real tough. You guys are learning lots of hard material all at once. Do you want me to put one of these questions up for you to try, and then we'll just kind of like call that for today? Your brains are probably getting full. Okay, I can do that. Let me put one up that is not anything like this one. Let me look one up. I don't know if this is going to go on the recording or not. Whatever. Perfect. I realize I'm focused a lot on sine. There's only 2 of them, so it's kind of... So this one is not like the one we just did. It obviously involves sine of x over x, because clearly that's part of it. but it is not done the same way at all. So why don't you guys see if you could just try to figure that out? I mean, use your reasoning skills that you guys are the best in the school at, because you make it to calc when you're good at reasoning, logical thinking. Actually, why don't I put another example up just so you guys can see some different ones? I mean, I'll work through them, but I realize some of you purposely try to black out trig. You see trig and you immediately shut off. Melanie, I don't think I called on you yet today. Melanie, do you have an idea how to start? I don't know, either one of these? You might not even looked at the pink one yet, but. Not really, okay. Oh, that's okay. Let's see. Mackenzie? Any thoughts on the one in blue? Okay, how about this? How about this, Mackenzie? Do you remember what sine squared means? What? What does squared mean? Yeah, that's all I was looking for. That's perfect. That's all I was looking for. Squared meant times itself. So, here's my thought. You guys should have tried one of two ways. You should have tried to do something with sine squared, or the squared probably brought back memories of the Pythagorean identity. So it's possible who's that? So did anybody do the one on the right? I don't know if anybody did. Honestly, I bet you it's going to work either way. That obviously it's totally totally different ways to do it. So sine x times sine x over x. If you guys remember the property that if you have two limits multiplied, you can split them apart and do two separate limits. So what I'm actually going to do is I'm going to write this as two separate limits. Sine of x over x, sine of x. Because the property says we can split it apart. This first one, the answer is 1. The second one, we can plug in 0, which is 0. So your answer is 0. I mean, I always hate when the answer is 0 because it feels like you do a lot of work and like answers nothing. But that would work. Let's try this other way because something tells me this other way is going to work. I said you're not going to solve it and not get an answer. When I say not get an answer, that means it like doesn't work. 0 is a totally valid answer. So 0 is like an actual number. So 0 is okay. 0 is always an okay answer. I know it might feel like it's nothing, right? Because we say nothing all the time. But 0 is always a valid answer. So the reason I think this way might also work is that top can be factored into 1 plus and 1 minus. It's the difference. Oh, erase that. And I'm going to use the same idea. I can split it apart. And I don't know if this is too small for you to read. I hope it's okay. So this left one is 0. And then 1 plus cosine of 0 would be 2, which is still 0. Honestly, you're frequently going to get questions that can be done totally different but still work. As long as what you're doing in the problem is correct, it's always okay. And then this pink one, I just kind of threw that one up there in case somebody thought the blue one was easy and was done quick and wanted to try another one. This pink one, tangent. So this involves your pre-calc methods you learned. If you're working with trig and you're stuck, one of the methods is to change things into sine and cosine. So I'm going to change tangent into sine of x over cosine of x. And then that x was already on the bottom of the fraction. Who asked that one? Cars. I suppose I can click over. Yeah, Carson. What did you mean? The property on the left. One. Like, I mean, I did 1 times sine of 0 as well. Is that what you were kind of asking? Limit times limit is 2. Yeah, that's okay. You can when there's multiplication, you can separate it into 2 different limits. It's possible you did the same thing, just kind of did a step in your head, and that's okay too. I'm trying to show out basically all the steps and everything. So if you kind of automatically knew to split it apart in your head, that works too. The pink one. Yes, you can look at it as one limit. The pink one, what I'm going to do is I'm going to keep this x with sine of x. And then the cosine of x on its own. So this is kind of the same question you were asking about, Carson. You're kind of asking I think you're asking if you have to write 2 different limits. You don't. You don't have to write them separate. If you want to just leave it all together, that's totally okay. I'm writing them separate so you guys know you can. Limit of sine of x over x is 1. And then the limit of 1 over cosine of x, I can plug in 0 and get 1 over 1. 1. So you're definitely going to get trig ones, trig problems that you can just plug in numbers and be done. You're going to get trig problems where you might have to change things around, like cancel factors, stuff like that. The only trig ones that are going to be different are if they involve these two special trig limits. And you kind of know if they involve them because it would have to have a sine of cosine at some point. The trig ones are the ones that you guys are going to probably hate the most because it's going to remind you of doing trig identities in pre-calc where you have to like change the problem around to look different to see if it works. There's no one method I can tell you that's going to work. So what I do when I try to do problems with you guys is just explain to you my reasoning and things I try. Sometimes things I try don't work, so then I would try something else. And that's kind of, you have to work through problems. That's kind of what the logical thinking and brain works as. Okay, so hopefully I didn't overload you too much today.